Next up, our next speech is also by a colleague of mine, Sergey Solonkin, Senior Test Engineer at Zabbix. And Sergey will cover the newly introduced browser monitoring in Zabbix 7.0, talk about the technical details of it and how it can be used to achieve your goals. Sergey, you are welcome.
Yes, thank you, Arthur. Give me a sec. I'll share my presentation. Can you see it?
Hold on. We can currently hear you and see you. We cannot see your presentation yet.
And what about now?
Yeah. Yeah, we can see it. Go ahead.
Okay, awesome. Thank you. Basically, yeah, my name is Sergey Solonkins. I work as a quality assurance engineer in Zabbix. As you all noticed, that Zabbix 7.0 has been released with multiple long-awaited features, and today I'm going to briefly introduce you to one of them, which is called browser monitoring. So the main approach that is used in browser monitoring by Zabbix is the so-called synthetic monitoring, where the monitoring tool using with the help of automated scripts simulates user activity on the web page under attention. The main features of such an approach are is that the monitoring is performed regularly, so you can detect problems with your web page as fast as possible. And secondly, you can define various scenarios to cover your functionality of your web page as much as possible so that you make sure that everything works smoothly as it should. And finally, it is important to note that such approach allows you to collect performance data and therefore establish performance baselines for future performance analysis of your web page functionality. So, yeah, the scenarios that are executed by browser monitoring Zabbix are written in JavaScript, and in fact, in this time they use the duct tape engine. This allows you to simulate various scenarios, starting from user login and logout from their account. For example, also filling data into different forms and submitting them, navigating through various paths through your web page, collecting values from different page elements, collecting attributes, properties, etc. And also this allows you to create more complex scenarios, the behavior of which changes based on the data available on your web page using the if-else scenarios. So, but before talking about the browser item itself, I would like to say a few words about the setup that is required to start browser monitoring with Zabbix. So what do you actually need to have? You need to have a Zabbix 7.0 version server or proxy. You need to have a Selenium WebDriver, and you need to have at least one of the 4 supported browser types, which are the Google Chrome, Microsoft Edge, Mozilla Firefox, or Safari. From Zabbix server point of view, 2 parameters need to be configured. The first one is the WebDriver URL, which basically represents the address that Zabbix would try to connect to when it connects to the WebDriver. And the second one is the start browser pollers, which basically defines the number of poller processes that will be started and will process specifically browser item metrics. Now, a few words regarding the configuration of the browser item itself. In Zabbix 7.0, the configuration form of the item has obtained a new item type, which is called browser. Same as for the script item, this item type has a parameters table, which includes parameter pairs with name and value defined, and also a script field. By the way, here you can see the default script, which is already predefined when you create a new browser item. Basically, what happens here? We create a new browser object, and afterwards we try to navigate to some URL, example.com. And right after we have navigated there, we retrieve the performance metrics from the browser. by using the collect perf entries method. And finally, we return the obtained result in the finally section. Now, the values of browser item parameters can be defined as plain text. They also can be defined as user macros, built-in macros, and also combinations of texts, user macros, and built-in macros, like it's displayed here. For the script itself, these parameters are received as a variable value, which has JSON format, so you need to parse this value first and then write its value into some variable. After you have done this, you can actually access each of these parameters by just specifying their name here, here, and here. Now, like for any other type of item, it is possible to define custom timeouts for the browser items. This can be done on Zabbix server level, on Zabbix proxy level, and for each item individually. Yeah, and by the way, but the default value for such a timeout for the browser item is 60 seconds. Now, as I've mentioned previously, the browser item is capable of collecting the browser-provided performance metrics. To do so, you need to use the collect perf entries method. This method has one parameter, which is called mark, and which is used to somehow give a name to the performance metrics that were collected at some certain point of your script execution. For example, here you can see that we have typed open page here just to say that the performance metrics were collected for opening the page. And in the received JSON, we will see a mark here with the data that we have written in this parameter. Yeah, the browser item is capable of retrieving individual metrics if you configure it to do so. But in most cases, it will return a result object that will contain great variety of data. This is why we would advise you to use the browser item as a master item and then use independent items with JSON path preprocessing step to get each metric individually for each dependent item. And this will allow to improve the performance of your setup quite severely. An example of such setup is displayed here. Basically, we have browser item, this one, that works as a master item. It receives data from the WebDriver with the help of Zabbix server or Zabbix proxy, and then each of the dependent items drag their required metric from the output of this browser item using the JSON path preprocessing step. Now, one cool feature of the browser item is that it's not only capable of retrieving some values, but it's also capable of retrieving the screenshots of the opened page in your browser. To get a screenshot of the browser, you need to use the getScreenshot method. As a result, you will get a base64 encoded value. Such values commonly occupy quite a lot of disk space. In order to save such a value, you need to use data type binary, which allows you to save approximately up to a couple of gigabytes of data, I think. I'm not sure about the limit for this type of data. One thing I have to mention is that the binary type of information is available only for dependent items. So basically, if you want to save a screenshot, you need to use the browser item as a master item and then create a dependent item with type of information binary that would obtain the screenshot using JSON path preprocessing. Yeah, the default dimensions of such a screenshot are 1920 by 1080 pixels, but you can actually change this screenshot size. You can increase it up to 8000 by 8000 pixels. In order to display the obtained screenshot, you will need to use the item history widget like it's displayed in this example. In order to get a better picture of what actually can be done by the browser item, it would be good to go through all the objects and methods that this item can operate with within its script. So the browser item actually operates with 5 main objects. The first one is the most important one, the browser object, which is responsible for the whole script execution starting from initializing the session to the very session closure. And during your execution of your script, you will interact with page elements. You will click on them, get some data from them. For this, you would need to use the element object. Also, you can interact with cookie and alert objects. All the results, all the performance data, all the statistics that is collected by the browser item is saved in a result object, which you will receive using the get results method. Such object will contain such information as, sorry, session statistics, for example, session duration, error information, if such errors have occurred, performance data, if you have collected some performance data by your script, and any other data that the user has specifically written into the result object. Now, as already mentioned, the browser object is the most important one. Therefore, it has the larger scope of available methods. Here, a short list of the main methods that are used by this object is displayed. The methods are grouped by the area of usage. So basically, when you tell your WebDriver to open a browser, you need to tell him which type of browser are you actually opening, and you need to tell him the parameters with which it should open your browser. For this purpose, we have the following 4 methods that return the default configuration for Chrome, Firefox, Edge, and Safari browsers, respectively. You can also configure some timeouts for your script. You can set custom script execution timeout, set session timeout, and set element wait timeout. An important thing that I would like to point out is that the browser item itself is not allowed to execute any custom scripts on the web page. By script timeout, we've meant that the scripts that are executed by the page itself. So the browser item itself cannot execute any scripts. When collecting data, you can collect performance entries by collect perf entries method, which already was mentioned previously. But this method aggregates the data, and then it also renames the data in such a way that it will be more understandable to the end user. If you like to work with the browser provided performance metrics as they are, you would rather use the get raw perf entries method, which is shown here. Also, you can get the result object by get result method and get screenshot using get screenshot method. If you encounter any errors, you can use the following 3 methods. Well, the get error object method will actually return an error object that will include all the error information like the error code, error message, etc. By set error, you can rewrite the message of the error, and by discard error, you can omit the error and just continue your script execution. There's quite a lot of methods available for you to operate with the opened page. You can navigate to some URL that you define. You can return the currently opened URL using get URL method. You can return the page source. You can get the alert object. You can get the cookies object using get page source, get alert, and get cookies methods respectively. And also you can add a cookie to the currently open page using add cookie method. When it comes to locating elements on the web page, there are 2 methods available. The first one, find element, it should be used in case if you are looking for a specific element and you wish to work further with one element only. But if you know that your search criteria applies to multiple elements and you would like to get them all, then you're advised to use the find elements method. When such an element is found, you can either get some data from it or you can interact with it. You can actually retrieve attributes, properties, and text of the web page elements using the getAttribute, getProperty, and getText methods. You can click on any page element. You can write any information into each page elements using send keys, or you can delete previously entered information using clear. Talking about alert objects and cookie objects, during your script execution, there might be cases when you encounter web page alerts, like in this example, we tried to disable a host and the following alert appeared. Well, basically, to interact with it, we use the alert object. What you can do with an alert, you can retrieve the text of the alert, which is disable selected host in this case. You can accept this alert or you can dismiss the alert. And the cookie object does not have any methods at all. So basically all you can do with a cookie is you can add a cookie to the currently opened page, or you can get the cookies of the currently opened page. In this short example, we opened some specific URL that is defined in the parameters of our item. Then we add a cookie using the add cookie method. The cookie itself was also defined in item parameters, and then we just retrieved the cookies from the currently opened page in the browser. The obtained results are shown here. Well, basically, you can see that there are two cookies inside this array. And the first one was the one that we have added in this here line with the name Zabbix 7.0 and value best release ever. Now that we know which objects the browser item operates with and what methods are available for it, we can go through a couple of short examples. But at first, I would like to talk about how the options and possibilities of how you can actually open a browser. By default, for Chrome, Firefox, and Edge browsers, the browser would be opened in the so-called headless mode. Basically, the graphical interface of the browser will not be launched. This is done for performance reasons. Unfortunately, Safari browser does not support such an option. So each time a browser item will execute on Safari, it will launch a graphical interface, which badly impacts the performance. There are some cases when you actually need the graphical interface to appear, maybe for some debugging reasons while you are writing your script. In that case, you can override some default options that are returned in the corresponding browser options method. For example, for Chrome, you need to empty the args parameter, just assign an empty array to it. Like in this example, same for Firefox and Microsoft Edge. And this will actually help you to launch the graphical interface for each execution of your browser item. It also might occur that the WebDriver is not aware of where the binaries of your desired browser are located. In that case, you will need to specify the path to the binaries of your browser in the binary parameter. Now, a short example, well, a form that we all love and know. And in this example, we will try to simulate user login using this form. Well, basically what happens here, we at first parse the parameters of our item. Afterwards, we create a browser object. And for this browser object, we navigate, which actually opens the browser, and we navigate to the URL that is specified in the parameters of our item. Afterwards, we now see this form. We find an element using its XPath. We find an element with ID that is equal to name, which corresponds to this input element. And using the send keys method, we type in admin here. We do the same for the password field for this one and type in Zabbix. And afterwards, we just locate a button with ID enter, which corresponds to the sign in button, and click on it. Easy as that. Now, in the previous example, in all three cases, we use the XPath as the selector, but it's not obligatory to use the XPath actually. You have also other options like CSS selector, link text, which basically represents the text of the element partial link text, tag name, and also the XPath. In this example, we will search for various elements in the list of hosts and retrieve some data from them. Here's the code. Let's go through each line one by one. Basically, in line 1, using the XPath, we locate a button with name equal to filter set and return its text. The obtained results are displayed here. So, and here we see that the text of this button is apply. Basically, it's this button. In the second row, we search for an element with text Zabbix server and retrieve its attribute data host ID. The obtained results show that the host ID of Zabbix server is 10,084. Then, using the CSS selector link action, which is equals to red, we search for the corresponding element and retrieve its text. So this text is disabled. Basically, that's the disabled link in the status column. Afterwards, we search for all elements that contain text with an empty space, text browser with an empty space afterwards, and count them using the length. So as you can see in the result, there are two such elements, and basically these are the host names in the first two rows here. And finally, we find an element by its tag name, which is h1, and retrieve its ID that corresponds to the page title. Basically, the ID is page title general. I would also like to draw your attention to how the errors are being processed, because during your script execution, you will definitely encounter some errors. The browser item is capable of processing two types of errors. These are the browser errors, which are automatically written into the result object once you create such an object. And secondly, these are the WebDriver errors. For WebDriver errors, you need to specifically cache the error using the setError method. In order for your item not to fail, you need to use, but actually to run till the end and return the result object, you need to use the try, catch, finally code blocks, like it's displayed in this example script. And you can actually take a screenshot right after you received an error of the opened web page so that you would know what exactly was displayed on the page when the error occurred. In this example, we tried to open some invalid URL that contains an empty space in the middle. And afterwards, we ended up in the catch code block where we didn't go into this if condition. We didn't need to set the error specifically because it was a browser error. So it was initiated and written into the result object automatically. So basically we create a result object, and afterwards we additionally write, get a screenshot of the page and write it into the results object. And then the result is returned in this finally block. Yeah, at the end, I would also like to mention that Zabbix 7.0 comes with one template that is based on the browser item. This template is called website by browser, and it's available under the template group templates applications. So what does this template consist of? It has one master item, which is a browser item, 26 dependent items that retrieve individual metrics using the JSON path preprocessing step, Three predefined triggers that are being fired once some metric has failed, or if website navigation is loading too long, or if some resource is loading too long. Nine user macros, such as browser type, website domain, screenshot dimensions, some timeouts, etc. Two predefined graphs, and one host dashboard. An example of this dashboard is displayed here. So basically, as you can see, this dashboard contains several graph widgets that display the data collected by the browser item, and an item history widget that shows the screenshot obtained by the browser item. That's it for me. Thank you for your attention.
Thank you, Sergey. We do have a couple of questions. Let's
Okay.
answer some of them here, and then let's try and cover the rest of them in text. What about iframes? Is the switch into iframes supported in browser object?
Currently, no, but I heard in a conversation with developers, I know that there is an active issue about iframe, and they already started thinking about it. So I guess we might expect that in the nearest future.
Thank you. Is it possible to fill in browser basic authentication, username, password dialog?
Sure.
That's, I think, a common one, a common question that people had with website monitoring, the old website monitoring. Is it possible with get errors to capture JavaScript errors that would normally be displayed in the browser web developer console?
I think that these type of errors might fall into the category of browser errors. I'm not sure for 100%, but I would expect them to be there. If not, then I guess we'll need some additional method to capture those, and that would be a nice idea for Zabbix next. But at this certain point, I cannot tell you for sure.
What is the minimal screenshot size?
Good question. The smallest screenshot size that I've tried to use is 100 by 100 pixels, and it worked.
Okay, so
I
if you
doubt
need
that
less than
there's,
that, yeah, do
yeah,
some testing. Um, Does the browser object support locate visible object or wait till some object is visible? Some web pages have loaded objects hidden and only make them visible after some user action.
at this certain point, there is a built-in wait for the object to be present. I'm definite that it will not wait for the object to be visible.
Mm-hmm.
If that is required for your setup, and I think that it also might be a very good thing to implement, because currently we are quite limited in the wait methods with the current state of the browser item. But actually, I've talked to developers again about the browser item in its current state and what are the future plans. I got an answer that at this point, we actually developed the very minimum that might be required. And after this, we need some response from the community to actually understand the direction where exactly we need to go. So there's a good chance of increasing this library of methods that Zabbix can use when interacting with the browser. So if you see that some vital method is missing and that it might be really needed in multiple cases, then please proceed and create a ZBX next. We will look into it.
Thank you, Sergey, for great examples, great presentation, and I hope browser monitoring and the capabilities of it are now clearer to all of our attendees. And as Sergey said, the work is always in progress, and if you are missing a feature or a method, feel free to create a ZBX next, and we will look into the community feedback and potentially implement it down the line.